that are in the range of whatever the length of the list is. Okay, so what else can we say about this? Not too much. Note that you could argue that we're violating a rule about functions in that we're using the crunch numbers function. There's only two functions other than main. There's only two functions in this program, crunch numbers and get duplicates. Well, the reason why we segregate get duplicates is because functions should be atomic. They should be cohesive. Each function should be cohesive, and each function should be loosely coupled with another function. Well, what does that mean? A function should just do one and only one thing. You could write this program in a single function if you wanted to, but you're violating a basic code of programming, which is you want everything to be atomic. You want an action to be performed only in one place and nowhere else. Why do you want that? Well, so if you have to make a change, it's easy to do. Maintenance is very simple if you only have to change one thing in one spot. So again, getting back to the point here, we're using crunch numbers to process both the tuple data, which are fixed, and the list data, which are random. Okay, so you could argue, well, you shouldn't be doing that, but it works pretty well in this situation. Okay, so that's tuples. Let's go on to dictionaries. Okay, dictionaries are a bit more complex. Excuse me. Right, so far, and I like the order in which he presents these. Lists and tuples just consist of a sequence of elements. Okay, and the major difference between the two is you can change a list, but you can't change a tuple. Now, dictionaries, on the other hand, see if I can find my slides. And before we launch into this, let me show you a couple of things here on the internet. Right, if we go to Google and we say, come on, there we go. Say data structures. In Python. Let's take a look at this first one here, Geeks for Geeks. And it will give you a concise description of each type of data structure, lists with an example of things you can do to it, dictionaries that we're about to look at, the way you set them up and things that you can do to it, tuples that we've looked at, which have clearly different characteristics, and then something that we're not going to talk about directly, but sets. Sets is a different type of data structure in Python that we looked at previously, but didn't really describe it as a singular data structure. Okay, and if you go through this page, it seems to be pretty helpful, but you'll notice that it's really not simply a matter of having only those four types of data structures. You have different variants of them, as you can see here, like frozen sets, strings, byte arrays, collections module. So what's a person to do? Not only that, not only are, if you use the internet to give you instruction about Python, a complicating factor in doing that is that with each release of Python, they make subtle changes to these things. For example, when this book was written, Murak's book, dictionaries were not in any particular order. That is, dictionaries which consist of values and keys and values, it could be rearranged without your control. Okay, well, it's not true anymore. Okay, so the point I'm trying to make is there are subtle differences to what you can do with these different types of data structures with each release. And by release, I mean 3.11.2 to 3.11.3 to 3.11.4. And stuff that you find on the internet might be out of date. In fact, it very possibly, very likely is out of date because you have these subtle changes that go on with each particular release of Python. And again, I find that kind of a hardship or a shortcoming of that code. Are in contrast, things that ran 10 years ago, almost without exception, run the same way now. Okay. And they did that by design so that you wouldn't write a program and then 2 years later have to change all of it. Okay. So what do you do? Well, the internet is still very, very useful for sure for finding, you get in a jam, you a particular situation, you want to try and figure out how to fix it. Internet will work with Python, but if you really want to go to the definitive source, use the Python docs. Okay, so you can find it on the internet. You can also find it on your computer where you've installed it. But for example, here's data structures in the Python documentation for 3.11.4. And so what do we have here? Well, we've got lists. You can use lists as stacks. Well, what does that mean? Well, a stack is a type of list, but it has a particular way that things get inserted and deleted. Typically with stacks, it's first in, last out. You can only add things to the front. You can only delete things from the back. You also have lists as queues, and queues have a subtle different property. These are all lists, but they're a little bit different. List comprehensions, we looked at. So we have different types of lists, nested list comprehensions. So that is the point I'm trying to make to you. In order to understand what sort of structures you have to start somewhere. But as you gain more experience programming in Python, you'll come to appreciate the subtle differences in uses of these different variants of each type of data structure. Okay, so let's go back over here to dictionaries. Let me get my notes. Okay, so here is the basic syntactical structure. And again, very easy to recognize the difference in creating one. You use the what are called the braces formally. These are called braces. I call them squiggly characters. And you have key value pairs, right? So instead of just having a sequence of elements of items, they're called items in Python, sequence of items that have different values, you have sets, if you will, of key value pairs. And unlike lists, which are accessed by the key, the index, the integer key, dictionaries are accessed by a key that's typically a string, but can be any immutable data type, right? So you access the value of items in a dictionary using their key values rather than their index. Now, I should also mention, I guess, of the four types of data structures, lists, tuples, dictionaries, and sets. The tuple is the only one that is immutable. Dictionaries, like lists and like sets, are mutable. You can add things to them, you can change the values of them, and so forth. Okay. So typically keys are string variables, but they don't have to be. Okay, here we create a couple of dictionaries. And let's see, let's do this. I have this code. It should be this one, slide 3. Yep, there we go. So we run this. And so we'll load all these dictionaries into memory. And then we can recall them. So that's countries. Here is numbers. Here's movie. Here's book catalog. And so in this first example, countries, we're using a string as a key. The country abbreviation, you can recognize it as. The string contains a 2-letter code for a country. Each key corresponds to the code for the country, and the name of the country is the value, which is also stored as a string. Now, if you did go out and buy the Murac book, there's kind of there is a misstatement in the book. If you look at, for example, the second example, we're using numbers as a key, right? 1, 2, 3, 4, 5. When Murac's book was published, Python was such that you couldn't count on it maintaining the sequence of numbers. And in fact, for efficiency internally, Python, according to Murac, Python may reorder the key value pairs in the dictionary at any time. I don't believe that's true anymore. I think the key value pair order is fixed, unless you do something like deliberately sorting it or changing the order yourself manually. Okay, the third example here, movie, just creates a dictionary that stores the data for a movie. And the fourth example is an empty dictionary. Well, what might be some of the uses or some of the scenarios where a dictionary data structure might be appropriate? Well, I'm in the education business, and most of the data that we store relate to individual students. So you might create a dictionary that has information about different students. And you can also, as we'll see before too long, you can create more complex dictionary data structures where you have dictionaries within dictionaries, just like we saw previously, lists within lists. But it's not that simple. You can combine these different data structures, so you can have a dictionary that contains lists and so forth.